so patient to wait for it to start. All right. So confidence intervals for P1 minus P2, meaning difference in proportions. And if you just have P, that's the true P, right? P is the true proportion. So we're trying to find the true difference in proportion. Your conditions, which are the same in both significance tests and confidence intervals. The only new thing is we have two of them. So this is important. When you're doing random, you have to have independent samples. Okay, so maybe I'm taking 9th graders versus 10th graders. So you can't have any overlap between them, all right? So your samples must be independent, and you have to state that. So instead of just saying random samples were taken, you'll say independent random samples were taken, because there's two, okay? And, of course, you have to check the 10% rule for both, right? So both of them have to be less than 10% of the total population. And then large counts, we did learn that yesterday. You got to check all four of them are greater than 10. This is n times p, right? And all the different ones for both samples. So for confidence intervals, this goes in the plan part. All right, this is the general formula that's given to you on the AP test. So we're going to plug in what we know and what we can learn here. So we're doing difference in proportions. So before, our statistic was just p hat, okay? When we were doing one sample, it was p hat. Now our statistic is the difference in the p hats. The order you subtract doesn't matter, all right? You may get positive values versus negative values. You just still have to interpret it correctly. It should be the same interval, just on one side versus the other side. So it's just how you interpret your answer, okay? The critical value for p's. What did we use, you guys? The critical value for p's is what? Z star. Same thing. Just, I don't know, special, just so you remember. So, of course, when we do this, you guys, to find that value, what button do we push on our calculator? Inverse norm, right? Inverse norm. And you have to know, like if you're doing 90%, remember you plug in half of it, 10%, 0.05, right? Okay. And then we multiply times the standard deviation, which before we just had one of these little p formulas under here, right? But now we have two, the one we learned yesterday here. And so all of these would be the first one, and then the second p. Now, if you know the true p, you plug it in. How often do we know the true proportion? Not very often, right? So we will use what's called the standard error instead of the standard deviation. So that's terminology you want to understand, right? Because sometimes they say just find the standard error. So just think standard deviation still, except we don't know the true p, we only know the sample p's. So this is the sample, or the standard error for p1 hat minus p2 hat when we don't know the true p. And so typically your formula is going to look like this. The same thing I just wrote down, except for with p hats, right? So we substitute in the standard error, because that's the best we can do, okay? And this test is called, so you might want to write down the name of the test, two sample Z interval for difference between proportions. I spelled that really well, proportions, all right? So make sure you remember you're doing proportions. When you look at the calculator to find this test, you want to find proportions, because there's one of them that looks similar to this one, and you don't want that test. You want the one that has the word proportions in it. All right, heads up. The book's not going to tell you to do the 4-step process anymore, but you still have to do it. This is because on the AP test, it's not going to tell you to do it. You just have to know to do it. All right? I'm sure they're looking for all that stuff, so I would do the 4-step, but I mean, you probably don't have to actually write the words state, plan, do, conclude, I bet. My guess is you don't, but I would just because that's me and I like to do that, but you guys do what you want, all right? You take the risk however you want to do it. All right. Teens and adults on social networking sites. So we're going to find the difference in proportions between teens and adults. So as part of the Pew Internet and American Life project, researchers conducted 2 surveys in 2012. The first survey asked a random sample of 799 U.S. teens about their use of social media and internet. A second survey posed similar questions to a random sample of 2,253 U.S. adults. In these 2 studies, 80% of teens and 69% of adults use social networking sites. All right, they're giving us the p-hats. That's in the studies, not in the actual true population. Calculate the standard error. So this could be a question, it's just the standard error. That's why you want to know what that formula is. So calculate the standard error for the sampling, distribution of the difference in the sample proportions, teens minus adults. What information does this value provide? What does it actually mean? All right, so let's calculate that. So the standard error of P1 hat and P2 hat all right, so we had our teens that are at 80% usage. So we're going to plug in 80%, and the other one would be 20%. So those are our p-hats. And underneath goes N, how many teens did we interview or sample? 799. Okay, plus in the middle. And over here we've got 69% of adults. So 0.69, 0.31, and we interviewed 2,253 adults. When you guys plug this in, if you're using the Inspire, it's helpful to use the divide key above the divide key. There's like that, I don't know if you guys know this, but it really helps you like plug stuff in correctly. This little fraction thing. I use that a lot if I'm actually calculating these. Okay. Anyways, we get 0.0172. And then it says to like explain what this means. What does that mean? What information does this provide, our standard error? And so this is that same formula or definition that I think I made you guys write down the other day. If we were to take many random samples of 799 teens and 2,253 adults, the difference in the sample proportion of teens and adults who use social media will typically be that far from the true difference in proportions, all right? So this is the distance from the mean, the typical distance from the mean. But, of course, you have to interpret it in the context of the problem, so make sure you do that. Okay. And then it says construct and interpret a 95% confidence interval. So back to confidence intervals, only with subtracting 2 different proportions. So our state, you guys, is no longer null and alternate hypothesis, right? So make sure you know that null and alternate hypothesis are for significance tests. So our state in this one is to define our P's. So P1 is the true proportion of all U.S. teens who use social media. P2 is the true proportion of all U.S. adults who use social media. All right, and of course, before we did significance level, so now we're doing the confidence level, right? So we want to estimate the difference, P1 minus P2, at a 95% confidence interval. Okay. Then we're going to plan, what's the name of this test, you guys? So P's always go with Z, right? And now we're doing 2 samples instead of 1. because we have two sets of data. So 2 sample Z interval. Why interval instead of test? Because we're doing confidence interval, right? Otherwise, you would do the test one. So 2 sample Z interval for P1 minus P2. Or you could say difference of proportions. If conditions are met, right? So what's the first condition we usually check? Random. What do we have to add, though, to this one now? Independent. Are teens and adults independent? Might be confusing for a while there in between, you know, when you're kind of growing up, but no, they're probably independent, all right? So, independent random samples. Again, you got to add that for these 2 sample ones. All right, and the next thing we check is 10%. So if I was checking 10%, we did 799 teens. So is 799 less than 10% of the population of teens? Yep. I'm going to shorthand this and not write it all out. All right, 2252 is less than, is that how many we did? 53. 10% of all adults, okay, in the whole U.S. This would be of all the teens. So we're good to go on our 10%. We can do the standard deviation. And so we know that it's normal. We check large counts. All right, N times P. So 799, and what percent did we get in our sample that used technology? 80%. Now, for calculator purposes, because we're going to use the confidence interval button on our calculator, I would like you to round to whole numbers. Okay? When you plug in these numbers into your calculator, which we're going to need, it will not do decimals. Okay? So you got to round. So this would give us about 639 teens who used social media. And then the weird 20% that don't is 160. I'm just kidding. And they're probably better off for it. And then other ones, we've got, let's see, our adults, 69% of them used it. That's 1555. And the rest of them that don't use it, 698. So do we have large counts? Yes. Why? Thank you. All greater than that magic number of 10 when you're doing proportions. Yes, Jake. I think it is greater than or equal to. Yeah. You can have 10. Just like 30, you can have 30. Okay? Okay, now for the actual do part. So, you guys always need to plug into the formula. You are welcome to use your calculator, though, for the actual part. And I would prefer that you do both. All right? I prefer you do both. So, on the AP test, it recommends using your calculator, okay? Because there's so many little errors, I guess, people make. But you have to know the formulas for, like, the multiple choice stuff and all of that. So every time you do these, even if the book gives you the answer from the calculator, I do want what you plugged into the confidence interval.
Why are we doing more than the book?
I know. Because you won't know how to do the test, trust me, if you don't just write it down. And it's not that hard, all right? It's not hard. All right, you guys. So for our test, or our confidence interval, all we have to do is our one formula that we just learned how to do, right? I just wrote it down. So you guys wrote it down. I'm not going to write the formula down again. It's this one, right? We subtract these two. The order does not matter. You just got to think about which one you're doing. I like to do positives, so I'm going to do my 80% first, okay, which was the teens, minus the 69% of adults. So instead of one p hat, we have a difference in those two, right? Plus or minus, and then we need our critical value, our z-score. You guys probably memorized the 95%, which is what we're doing. You guys remember? Okay, 1.96. If you don't remember, you have to do the inverse norm. All right, and then we got to do our standard error. However, didn't we just calculate that up there? In part A, it asked us to actually calculate the standard error. We plugged all that in and got 0.0172. So I'm going to go ahead and just write that down. Yeah, you can round or store, it doesn't matter. They are not very picky. So multiply these, subtract these, add and subtract, right? And you should get 0.076, comma, 0.0143. And then we have to interpret, okay? So make sure you substitute these in, and typically you'll actually substitute that whole formula in, right? Because we won't have actually calculated it. So just a reminder how to interpret a confidence interval. We are 95% confident that the interval from 0.076 to 0.113 captures the true difference. So you're adding in that word, right? The true difference in the proportion of all U.S. adults and teens who use social media. So is there evidence of a difference, you guys? Is 0 in the interval? That's what you're looking for when you're estimating a difference. If 0 is in the interval, you cannot say there's a difference. However, there is probably a difference. And who probably uses more social media? Teens, right? We got positive values that the difference is between like 7% and 14%. Does that make sense? So if 0 is not in the interval, there is difference. But we just have to conclude it like this, okay? And then you got to be able to do it on your calculator, of course. So we're going to plug into our calculators. So go to confidence intervals. Okay, menu, stats, and confidence intervals, because we're doing confidence intervals again. And what you have to be careful of is you do not use that 2-sample z-interval. So this one right here, you guys, the 2-sample z-interval is actually for means when you know the population. Because you can use a z-score when you know the true standard deviation population. We do not typically know that, so you're not even going to use that very often. So the one you're looking for is a little further down. Always look for the word proportion, okay? So 2 proportion z interval. And we're going to plug in.
Menu 666.
What did you say?
Menu 666.
That is great. Thank you for pointing that out. Now that we're all feeling good about this, statistics, confidence intervals. Okay. So we have to do x1. Now, they didn't actually give us x1 in the problem, so you're going to have to calculate it. x1 is the actual number of successes in the sample. So we found that 80% of the 799 teens, right, that were in favor, success, they actually use social media. So you have to round, and that's why I'm having you do rounded values, is for that number right there. You have to do 0.8 times 799, okay? And then n is 799, so that's your teens that use all of them that we interviewed, okay? And then your x2 would be the successes of adults, so that's the 69% of 2,253, which was the 1,555 number out of 2253. Our confidence level is 95%. Press OK. And go up to see it. So we've got our interval. You got a domain. You have to round.